All right, looking at G. So G in this homework, we have 3 terms. So immediately you want to think about using the snowflake or traditional method. Remember that you always want to try to factor something out though. So if these 3 terms have a common factor or a GCF, we're going to do that. So since all 3 of these terms can be divided by 3, we would definitely do that first. So we're going to take out a 3 from those terms. So we're going to factor out a 3 and then rewrite this by dividing each term there by 3. So this is going to become 4x squared minus, this would be 13x, and then plus 3. Then we'd keep on going. We took out the 3, and now we're left with a trinomial here that we would want to try to factor. And we want to basically try to use that snowflake method to see if we can go further on it. So let's give it a try. So we have a term of 4. 8 times c is 12, and we have negative 13 down here. And so what multiplies up to 12 and adds up to negative 13? Well, that's going to be negative 12 and negative 1. So it is factorable. We do want to reduce our columns here. So 4 over negative 12, that can be reduced down to 1 over negative 3. So that's 1. And then we also have 4 and negative 1 right here. So our factoring, this red part would become 1x minus 3 from this, and also 4x minus 1. Don't forget the 3 that we factored out from the first part of the problem. So we're going to bring that 3 down, and we would be left with this as our complete factorization. The strategy that we used here is going to be, first we use we factored out a common factor. So we can just put GCF there. We factored that out. And then I'll just put here, we just used snowflake, which is our kind of go-to when we factor a trinomial. All right, H. We're looking at H. We have 4 terms here. So I'm going to try grouping here. We're going to try grouping, and also note here that we do have a common factor. Everything can be divided by 2. So there might be a couple different ways you might approach this. So when I see this, everything can be divided by 2, I'm just going to take that 2 out. Everything can be divided by 2. So I'm going to take out a 2 and rewrite this whole problem as x to the 4th plus 7x cubed minus 8x minus 56. And then from there, we can go ahead and we can try our factor by grouping. So now we're left with this black part, which is still 4 terms. We can try to group this and do factor by grouping. So let's say we take this and we group it up into 2 separate pieces here, like right there. So I have this piece right here, and I have this piece right here. We have 2 separate groups, and I'm going to try to factor out the greatest common factor from both of these things. So again, just thinking about that black part, from this first group, both of them have an x cubed. So I'm going to take out an x cubed from that first group, which is going to leave me with x plus 7. I know that I still have a 2 out here, but I'm just going to ignore that for now. I'll bring it down once I'm done. The second group, you can see that there's going to be a 7 that is in common. Between 8x and 56, there is a 7 that's in common, and really it's a minus 8x here with that group. Now, the trick here is I want this right here to be exactly the same when I pull out my common factor right here. So I have a choice. I can take out an 8, or I could take out a negative 8. And so you're going to see that taking out the negative 8 is what you want, because if I take out a negative 8, then this term right here will be plus 7, and it will match with this plus 7. If I take out a positive 8, then it's not going to work out like I need it to work out. So the second group, I'm I'm going to write this as plus, and I'm going to take out from the second group a negative 8 from that. I'm going to take out that negative 8, and then from the second group, if I take a negative 8x, if I take a negative 8 from there, that would just be normal x, or positive x. And then negative 56 divided by negative 8 is my plus 7 there. So this is exactly what I need. So I do have an x plus 7 and an x plus 7 that is in common. So this factor by grouping problem now would be x cubed minus 8, kind of the black parts here. And I also have this x plus 7. That's that common factor there. And then I don't want to forget about this 2 that I factored out a while back. This 2 is going to come back down here. And so I factored it to that so far. So this is a tricky one because there's more to do, right? Clearly I can't factor 2 anymore. I can't factor x plus 7 anymore. But can I do more to this? Can I factor x cubed minus 8? Yes, you can. X cubed minus 8 is the difference of cubes, right? So I have the difference of cubes there, and so I'm going to take this as a separate problem. Now I'm just going to put this, just to make it a little easier to see, I'm going to put this over here, and really I got to figure out how do I factor the difference of cubes. Where I have the 2 and x plus 7, that's not going to change anything. So difference of cubes, what is that pattern? And so the pattern for the difference of cubes pattern is right here. Oh, that's not the right one. I need the difference of cubes. There it is. So here's what the difference of cubes pattern looks like. And I'm running out of real estate here, so I'm going to make this a little smaller. So I'm thinking about, okay, again, I have this x cubed minus 8. Well, that matches up with my difference of cubes right here. And that x cubed minus 8 then can be expanded out or factored to now this right here. So again, just kind of ignoring that 2 and x plus 7, this x cubed minus 8 will become a minus b, which again, my a value here is going to be x. And my b value is going to be 2, right? Because this is the difference of cubes. If you don't see that, what I'm talking about here is x cubed minus 8 is the same thing as x cubed minus 2 cubed, right? So my a value is x, my b value is 2. So this will become x minus 2 times this part, a squared or x squared, plus ab, which that would be x times 2, or 2x, plus b squared. In this case, that would be 2 squared, or 4. So there you have it. The x cubed minus 8 now factors to this guy right here. And we already have the 2 and x plus 7 that was already done with the factoring. So we're going to bring that down. And then I would look at, this is kind of a long factoring problem, this right here. We'd say, hey, can you factor this? This looks like traditional snowflake. Could I just factor that down more? And I'll tell you right now, you can't, right? Because if you think about it, there's nothing that multiplies up to 4 and is going to add up to 2, right? So you could try snowflake here, but it's just not going to work out. It's not factorable. So this is as far as you can go, and this was a more challenging one. But the strategies that I used for this one, well, first we used the GCF strategy. We factored out that. And then in this step right here, we used factor by grouping. So I'm just going to put grouping here. So we factored by grouping. And then we got to this stage right here, and then we had the difference of cubes. So I'm going to put in difference of cubes, and then we use that pattern to figure that out. And that's as far as we went. So we used 3 things there. So quite a bit. Okay, so let's look at I. I is over here. So again, we have 3 terms, so I'm not thinking about any factor by grouping. definitely, though, we're going to use that GCF, right? We're going to take out a common factor between all three of those terms. And it looks like everything can at least be divided by 2. And since the leading term here is -4, it's kind of nice to factor out a negative so that that leading term becomes positive. It's not something that you have to do, but it's often done just to make things nicer. So I'm going to take out, I know everything here could be divided by a 2, and I'm going to make it divided by -2. So I'm going to pull out a -2 here and see what we have left over. Okay, so if I take out a -2 or divide that out, this would become 2x to the 4th plus or minus 13x squared, and then plus 15 if I divide everything by -2. And then again, we're going to look at this black part right here and say, can we factor this? We have a 3-term. We have something that's 3 terms. And so we're going to go ahead and try the snowflake method, right? So let's try snowflake. In this case, my a value is 2. My a times c is 30. My b is -13. And so I'm thinking about what multiplies up to 30 and adds up to -13. So that's going to be 10 and 3. So I'm going to say 10 and 3 here. And both of those would have to be negative, right? -10 and -3. Again, -10 times -3 is +30, so that works. And -10 minus or plus -3 is -13, so this works out. Go ahead and reduce the columns as we need. This one's already reduced. We have 2 over -3. We can't divide, can't reduce that column. This one we can divide because we can divide a 2 with both of these numbers. So this would become a 1 over -5, and so that column becomes this. So my snowflake method then expands to 1x minus 5. Again, here this is not going to be x, though. It's going to be x squared minus 5, because the first term in my trinomial is really x to the 4th. So we're going to think of that as x squared minus 5, not just an x. And then the second column is 2x minus 3, 2x squared minus 3. And again, this term that I took out from the very beginning, -2, I still have that. I'm going to bring that down here because that just is going to come down to the side here. So now I'm looking at this, see if it's completely factored. If you're unsure that this part is right, you could always multiply it and see if it does, in fact, equal 2x to the 4th minus 13x squared plus 15. It does. So this is correct. The only other question we might have is, could I factor this thing separately? Is this like the difference of 2 squares, or is this the difference of 2 squares? And none of those are. We don't have any special, you can't go beyond that, basically. So this is as far as you can go for this one. So that's it. And then the strategies here, we use GCF, and then we used Snowflake for the strategies. All right, last row here. Okay, Jay, hopefully you're getting better and better at these problems. Jay, the first thing you want to do here is take out the common factor for sure. Each one of these can be divided by 5, and they also have an x there. So if you take this GCF out, you can divide everything here by 5x. I'm going to pull a 5x out and rewrite this problem as 3x squared, and 5x divided by 5x, well, that's 1, so that would be minus 1. And then the question is, can I go further? Can I do that anymore? And you can't. Now, if you're asking the question like, well, how do you know you're done there? I mean, you could try to snowflake that. here's what it would look like. 3x squared. There is no middle term. So 0x minus 1. If I try to snowflake that, my a term is 3 and 3. My a times c is negative 3. My middle term is 0. The reason why this doesn't factor is because there's nothing that can multiply up to negative 3, but also add up to 0. If you think about it, the only way that would work to add up to 0 is if you had opposite numbers here. And both conditions are not going to work here. This is not going to be factorable. And so you're stuck here. Now, if you go through this process and try snowflake and then realize, oh, can't go any further, that's fine. But it comes with experience that you would just be able to look at this and say, yeah, you're not going to factor that. So this is as far as you can go. Now, what strategy did we use here? We really just used GCF. Just pulled out the greatest common factor there. All right, K. This one looks simple because I have 3 terms. There's no GCF there. There's nothing I can pull out there. So it looks like I'm just going to use like the snowflake method and do my 2 parentheses and be done here. So let's see if this factors. I have a trinomial with just the a value of 1. A times c is 45. And the b term is negative 14. So what multiplies up to 45 yet adds up to negative 14? So that'd be, think about that, would be 9 and 5. So 9 times 5 is what we're looking at here. However, it looks like we're going to have a problem. So 9 times 5 is 45, but 9 plus 5 is 14. So we got to make both of these negative, and then it's going to work out. So negative 9 times negative 5 still makes this true, and then adding up those is negative 14. So that does work. We don't have to reduce these 2 columns that we have, so there's going to be my 2 parentheses. 2 parentheses would be 1x minus 9, or x minus 9, and then 1x minus 5, or x minus 5. So that's it. Strategy there is just snowflake method or that trinomial with just an a value of 1. Last one, 64x cubed minus 1. Nothing to pull out here. You can't pull out a GCF. This is a difference of cubes, though. So this is another pattern here where 64x cubed can be written as 4x all cubed. So that's actually a perfect cube. 4x times 4x times 4x is 64x cubed. And we can also write 1 as a perfect cubed if we just did this. So we can rewrite this and say, hey, this is a difference of 2 cubes. Therefore, we can use our little difference of cube pattern that we have from up here. So here's my pattern that I'm going to use and refer back to. Of course, in this problem, the a value is 4x. So a value is 4x. I'll just write that over here. The b value is 1 that you can see, and we're just going to follow this pattern along. So if we expand that, we're going to have a minus b, so 4x minus 1 times a squared, which would be 4x squared, or 4x times 4x, which would be 16x squared, plus ab, 4x times 1, plus b squared, which would be 1. And so there we use the difference of 2 cubes. Now the question would be, is it possible to, clearly this first thing right here, 4x minus 1, is already factored as far as that's going to go. But can you take 16x squared plus 4x plus 1? Is it possible to factor that any further? Now, again, I've done so many factoring problems that I know that's not factorable. But again, if you tried snowflake and you test it out, you're going to realize that there's nothing there that's going to work. You can go ahead and try that, but that's as far as you can go in that problem. This is it. The only strategy that we used here is the difference of cubes. So that's it for the homework. Hopefully you're getting better and better at factoring. Again, some of the major things in this homework is, the strategies that we've used. The number one is always to check if we have a greatest common factor. That's the first thing you always want to apply when you're doing any factoring problem. GCF. Is there a GCF that I can pull out? And that's always the first thing you want to double check on before you do anything. After that, you can see like we use the traditional snowflake method for a lot of these problems. When it's a 3-term polynomial, snowflake traditional method is going to work out all the time if it's factorable. And then some other things that we note here is if it's 4 terms, it's a little bit more rare, but if you have 4 terms here, oftentimes, if it is factorable, you're going to use factor by grouping. And then on top of that, you have some of those special cases. You have sum of cubes, you have difference of cubes, you have difference of squares, and things like that. So if you understand all of this and all those strategies, it's really, really good. If you continue your math on beyond Algebra 2, you'll be doing this in trig and in pre-calc and in calc. This doesn't go away, so it's good to get better and better at factoring.